Hello, class. Today we're going to go over notes on 6.1, evaluating nth roots and using rational exponents. We're going to start with some basic roots that we're going to simplify. For the first problem, we have the square root of 4. To figure out what the square root of 4 is, we think to ourselves, what number times itself will equal 4? Well, that number is 2. The square root of 2 times 2 is the same as the square root of 4. So our final answer is 2. For the next problem, the square root of 81, we would do 9 times 9. So the square root of 81 is 9. Now that should be review. You've been doing square roots for quite a while now. For number 3 and 4, however, we have cubed roots. This may be a little newer for you. Cubed root means what number times itself 3 times. So for this cubed root of 27, what number times itself 3 times equals the cubed root of 27? Well, 3 times 3 times 3 is 27. So this cubed root of 27 is 3. For number 4, we have the cubed root of 64. Well, 64 is 4 times 4 times 4. So the cubed root of 64 is 4. For number 5, we have the cubed root of negative 8. So we have a negative number under that root. For negative 8, we think to ourselves, what number times itself 3 times equals that negative 8? Well, if we do negative 2 times negative 2 times negative 2, that does equal negative 8. So the answer for the cubed root of negative 8 is negative 2. For number 6, the cubed root of negative 1,000, we would want to use negative 10 times negative 10 times negative 10. So the cubed root of negative 10 is, the cubed root of negative 1,000 is negative 10. For 7 and 8, we're looking at fourth root. So now for the fourth root, it's what number times itself 4 times. So for the fourth root of 81, well, I know 81, if you're not knowing this offhand, you can create a factor tree, is 9 times 9. Well, and the 9s are 3 times 3, right? So if we do 3s, 3 times 3 times 3 times 3, that would equal 81, which means the fourth root of 81 is 3. For number 8, we have the fourth root of negative 16. So we have to see, is there a way to take a number multiplied by itself 4 times to get negative 16? Well, if you think about it, it's a negative number. And if we're multiplying 4 numbers together, and we're trying to get an answer that's negative, that's not really going to work, right? Because even if we did negative 2s, those negatives would cancel out. Negative times a negative is a positive, and we have 2 sets of those, right? So we'd have a positive times a positive. So for this one, it is no real solution. Okay, so when you're taking the even root of a negative number, there's no real solution. Okay. Now notice here, a couple of notes here. It says radicals can be written as exponents. So that means a root can be written as an exponent. It also says that rational exponents are fractional. Okay. So we are going to practice using fractional exponents here today. So if you look, we say here if x is greater than 0 and m and n are positive integers, then the x to the m over n will equal the nth root of x to the mth power. So what that means is, as an example, if you have x to the 2/3, that bottom number of your fraction is what your root's going to be. So it would be the cubed root of x, because 3 is the bottom number in your fraction. The top number in your fraction is the exponent, so it'd be to the second power. Those two things mean the same thing. So in 9 through 11 here, we're going to rewrite the expression as fractional exponents. So we're just going to change these roots to exponents. So for number 9, the square root of 3, well, square root means there's a 2 in there, right? So it would be 3 to the 1/2, because whatever the root is, that's the bottom number of your fraction. For number 10, the cubed root of 10, that would be 10 to the 1/3. And for number 11, we would do 11 to the 1/2. Okay, so 1/2 is the same as square root. Now for 12 through 14, it says rewrite the expression using radical notation. So what that means is we're going to change this. We're going to write it as part root and part exponent. So you have to remember the bottom value in that exponent, the bottom value of that fraction is your root. The top value will remain the exponent. So for number 12, x to the 2/3, that 3 becomes our root. So it's the cubed root of x, and then that whole thing will be to the second power. For number 13, x to the a over 5, the 5 is our root this time, so the 5th root of x, and that's to the power of a. For number 14, x to the negative 3/4 be the 4th root of x to the negative 3rd power, if you're just writing it as radical notation. Okay, so for 15 through 17, we're going to rewrite the expression using rational exponent notation. So that means we're going to rewrite these as exponents. So for the cubed root of x to the 5th power, if we want to change that root to an exponent, we would have the x, the 5 is the top number because it's to the 5th power, and then we create a fraction. So it'd be 5 over, since it was the cubed root, it'd be over 3. So x to the 5/3 is the same as the cubed root of x to the 5th power. For number 16, we have the 4th root of x to the 3rd power. So for the 4th root of x to the 3rd power, we would rewrite this as x to the 3 on top, and since it's the 4th root, 4 is on the bottom of our fraction. For number 17, it's the square root of x cubed. So this would be x to the 3 over 2. Okay, for the next set of problems, we're going to evaluate without using a calculator. So we're going to use these skills we just learned to figure out what the answers are to these problems. So for 18, we have 125 to the power of 2/3. Remember that top number is our exponent, the bottom number is our root. So this is the cubed root of 125 squared. Well, the cubed root of 125 is 5, and 5 squared is 25. And that's your final answer. For 19, we have 8 to the negative 4/3. Remember that 3 on the bottom is our root, so it'd be the cubed root of 8 to the negative 4th power. Well, the cubed root of 8 is 2. And for 2 to the negative 4th, we can't have a negative exponent. So we would need to make this a fraction, 1 over 2 to the 4th, right? Because whenever you move it, it becomes positive. So our final answer is 1 over 16. For number 20, five to the 1/2 would be the square root of 5, times 5 to the 1/2 would also be the square root of 5. So square root of 5 times the square root of 5 would be 5, because the square root of a number times the square root of the same number equals whatever number is underneath. For number 21, 4 to the 3 halves. So for the 4 to the 3 halves, the 2 on the bottom is our root, so it'd be the square root of 4, and then we'll cube it. Well, the square root of 4 is 2, and 2 cubed is 8. For number 22, we have 27 to the negative 2/3. So we're taking the cubed root of 27, and then it's going to be to the power of negative 2. Well, the cubed root of 27 is 3, so I have 3 to the negative 2. Now remember from the previous example, we can't have a negative exponent, so to fix that, we'll move it and put this as 1 over 3 squared, which means your answer is 1/9. For number 23, we have 32 to the 3/5. So for 32 to the 3/5, we have the 5th root of 32 to the 3rd power. 5th root of 32 is 2, and 2 cubed is 8. Now on your test, you will need to know how to do these without a calculator. However, it's also good to have the skill of being able to use a calculator to solve them. So go ahead and practice 21 and 22 on your own with a calculator. If you have any troubles with that, make sure you talk to your teacher so that they can problem solve with you and fix any issues you have using a calculator on those problems. Now for our last section of examples today, we're just going to solve equations. So we're going to use the knowledge that we have of exponents and roots to solve for x. So for 24, we have 6x to the 3rd power equals 384. We want to get that x to the 3rd power alone. So I am going to divide both sides by that 6 first. That would be our very first step. So that gives me x cubed alone. For 384 divided by 6, 6 goes into 38 6 times. When we subtract, we get a 2 and bring down that 4. 6 goes into 24 4 times. So x cubed equals 64. From there, I want to get rid of the cube, so I'm going to take the cubed root of both sides. The cubed root of x cubed is x. The cubed root of 64 is 4. So your final answer is x equals 4. You can always plug these answers in to make sure you did the problem right. So you can plug them into the original problem and simplify. For 25, we have x plus 5 to the 4th power equals 16. So for the 4th power, that's what we want to get rid of first. I'm going to take the 4th root of both sides. Now this is an even root. Since it's an even root, it's just like when you take the square root of both sides of a problem. This is the absolute value of x plus 5 equals 2. You're going to have two answers. So we would split this up. X plus 5 can be a positive 2, and x plus 5 can be a negative 2. And then we will solve both problems. So you should get x equal to negative 3 and x equal to negative 7. For 26, we have x minus 2 cubed equals negative 27. We want to get rid of that cubed first. So I'm going to take the cubed root of both sides. This becomes x minus 2, no absolute value because that was an odd root. And the cube root of negative 27 is negative 3. Then I would add 2 to both sides to get a final answer of x equals negative 1. For number 27, we have 2x to the 4th equals negative 32. We do want to divide by 2 first to get x to the 4th equals negative 16. Then we would want to take the 4th root of both sides to get x alone. However, we have the 4th root of a negative number. And remember from the beginning of the notes, that has no real solution. So your answer here is no real solution. And that's it for notes today. If you have any questions, be sure to contact your teacher.